Hello, welcome to lecture 9. Today I'm going to talk about real numbers. This is mathematics for class 10 based on chapter 1 of NCERT syllabus. My name is Sangam Banerjee and my details are given below. So I would request here students to go to my class 9 lecture 10 for the sake of completeness and also for understanding in greater depth. So I will request them to go to my class 9 lecture 10. Okay, I've taken this from class 9 lecture 10. This is types of real number which you can, this is your real number line. So you have natural numbers which we call as n. Then we have a whole number with the natural number 1, 2, 3. You add 0, then you get a whole number. This set and this set belongs to this bigger set. And then if you take negative number also, then you have an integer number z. Then you can have fractions. Okay, any integer divided by integer is a fractional. So this can be also called rational numbers. In rational number, we will come to this. You should have here co-primes, and then you have irrational numbers, which is non-terminating numbers, but you can plot geometrically in a number line. Like this is an irrational number, square root of any natural number. If this number is not a perfect square, then we will show in this lecture that then it becomes an irrational number. This is the value of e and this is the value of pi. And the value of pi is the ratio of circumference of any circle to its diameter. Now I can break this real number to, as I said, there are rational numbers which are a ratio like a fraction. This is an integer, this is an integer. We will come to it. This can be reduced to co-primes. And you have irrational number which cannot be represented as a ratio of two integers. And this rational number can be again divided into two sets, that is fraction, that is a ratio of two integers and integers from minus infinity to plus infinity. And this integer have negative integers, that is minus infinity to minus 1, and whole number that is 0, 1 to infinity. So this covers this whole range, and this whole number can be 0 or a natural number that is from 1 to infinity, and this natural number can be either prime or composite, even and odd. I will not go into more details, so I will request you all to go to class 9 lecture 10. Okay, now we will discuss some properties of set of numbers. Here we will start with only two numbers, say 3 and 4. So one of the properties is this number 3 and 4 can be a common multiple to some other number. That is, you see here, you start with 0, this is 3, and then 4. Again you jump 3 here. So if you continue jumping, and this will go to 4, that 4 plus 4 is 8. So it will meet at this number 12, and this is the first time it is meeting, and it's called the least common multiple. You can have, here see, I have taken 2, it is jumping 2. And this is jumping 3 times, 0 to 3, then 3 to 6, then 6 to 9. So the first time this number is meeting is at 6. Then again it will meet at number 12. And the third time, third common multiple will be 18. So, but this is the least one, the first common multiple. We call it 6 is the least common multiple. So this is pictorially to understand. Of course, you can do with many more numbers, many more this kind of jumps you can put, 3, 4. You can extend it to many numbers. So, and then there is some other property called the highest common factor. So if you have two numbers, say you have number 12 and number 16, and we know that factor of 12 is 1 goes to 12, of course, 2 will also go, 3 will also go, 4, 6. 6 into 2 is 12, and 12 of course will go one time. And factor of 16 is 1, 2, 4, 8, 16. So among this, which is the highest, 4 will go to 12, and here 4 will also go to 12. But not 6. 6 will not go to 16, nor 8 will go to 12. But definitely the highest one is the 4. 4 will divide 16, and also 4 will divide 12. So this is the highest number which can be used to divide both the number to an integer number. So this is called the highest common factor. So least common multiple of two numbers is the lowest possible number, is a single number that can be divisible by both the number which you have taken. Okay, the two numbers. So to repeat again for your better understanding, here this number 2 and 5, and you see 10 and 10 I can, 5 I am jumping here, 5 2s are 10, then 3s are 15, 20. So if you see this line and this line, this 10 is there in this line and this line, and in this line you have 20 here and 20 here. So this is common. So this is the first multiple, this is the second multiple. So with least common multiple is the least one, so 10. So 10 is the least common multiple of 2 and 5. And here multiple of 4, if you do do it and multiple of 5. This is common here. You see 5, 10, 15, 20. Here 4, 5s are 20. Then this is a second. So least common multiple is 20 of 4 and 5. This is how one can find very easily that you take 2 and 5. 2 goes to 2 one time. It doesn't go. So you bring it down. Then 5 goes to 5 one time till you get 1 here. So 2 into 5. So this is also way of finding LCM. Another example. 6 comma 15. So 2 will go to 6 3 times. It will not go to 15. You bring 15. Then 3 will go into 3 one time and 3 5s are 15. So 3 into 5 is 15. Then again you take 5 till you get this 1. Okay, this you have been definitely by this time in class 9 I have explained this in greater detail. So now 6 is 2 into 3 and 15 is 3 into 5. So 3 already has been taken here. 2, 3 into 5. So LCM is 2 into 3 into 5, that is. So LCM of 6 and 15 is 30. So this is how you can find by writing it. Another example 4 comma 5. So here you start with 2, it divide. If suppose some other number is there, 7 is there, then of course you start with 5, then 7, 5, 7. So 5 and 7 will be 35. But in this case it is 4 comma 5. You start with 2, then 2 goes into 4 twice time. 2 into 2 is 4. So 5 you bring it down. Then in this 2 will go one time. 5 you again bring it down because 2 doesn't go to 5. And then 5 will go to this 5 one time. This one you bring it down. So till you get this 1. And this is in this side, in this column, you multiply all. So LCM is 2 into 2 into 5, that is 20. So this is how you can find by writing instead of going through this kind of step where this 20 is the least common multiple. Now we discuss highest common factor. The highest common factor of two number is the highest possible number, the single number that divides both the number which you are taken into consideration numbers completely. The highest common factor is also called as greatest common divisor. So some people call HCF, some people call GCD. So both are same. So what does it mean? That suppose factor of 18, 1, 2, 3, 6, 9, all of them goes into 18. And here factor of 27, 1, 3, 9, 9 3s are 27. 27 of course go to 20. So you see here 1 is common, 3 is common and 9. So this is the highest common factor, okay? From 1, 3, 9, this is the highest common factor. How do you find it? It is also very simple to find. Again you do very similar. You separate it here. 18 and 27 you do. And 18 is 2 into 3 into 3. These are the prime numbers. And then you have 27 is 3 into 3 into 3. So this is the common factor. This is 3 into 3, 9 and 9. Okay, so these two 3s are common. So GCF is 3 into 3 is 9. So here what you do is, see this is I have labeled in blue circle, 3 and 3 is common here. So you don't have to take this 3 because only 2 3s. These 2 3s are common. So 3 into 3. And if you want to take LCM, then you have to take 2, 3. Only 2 3s are there. But it has 3 3. So this is an extra. So in an LCM you have to multiply 2 into 3 into 3 into 3. Here only 3 into 3 for GCF. So here I have written LCM is 2 into 3 into 3. This is 54. 2 into 3 into 3 into 3. And there is another property that LCM of AB into HCF of AB is nothing but A into B. Okay, we will prove this. So here what we have seen is LCM of AB, this is 18 and 27, is 54 and GCF is equal to 9. So I can write 54 into 9, LCM 54 into 9 is equal to A into B. A is what? 18 into 27. 18 into 27 is 486. This is also. And we will prove this. This I have just demonstrated it, but we will prove it. And what is this greatest common factor of 18 and 27? You can do by division method. We will come to it also. That is 18 and 27. 18 goes one time to 27. So you subtract, you get 9. Then again you bring this. This is your dividend. This is divisor. This is the quotient. So you bring the divisor here. We will come to this in next few slides. So again 9 goes to 18 two times. So minus 8, 9 to the 18 minus 18. So remainder is 0. So this is your greatest common factor. It will be clear in next few slides. So suppose you have three numbers 18, 27, 36. As I said, you start with 2, then if doesn't go 2 you take 3. You should take prime number here. 2 goes to 18 9 times. 27 it doesn't go, bring it back 18 times. So this you follow here, and this what you get is, this is the product 2 into 2 3 3. This LCM is 108. And here I have shown here what you mean is, see here 18 is 2 into 3. So 2 threes has been taken into account, but here there are 3, so one more it is there, so you have to add this. And here only 1, 2 was taken into account, so this is an extra 2, so that also you have to take into account. So it's same, 2 into 3, 3, 3. So these are the things involved. Okay, you don't have to repeat here. And in HCF, you take the repeated one. And in HCF, you see here, you can do like this, you make column, and you have to take a common whichever goes. So once it doesn't go, you have to stop. So here 3 will go in all, so you take 3, 6, 9, 12. Then again 3 will go, 3, 6. This is a common. So 3 into 3, this is the HCF, that is 9. Okay, by now I think I have repeated so many times that you should be knowing it. Again, let us continue. So factor of 18 is 2 into 3 into 3. Factor of 27 is... So what are common? These 2 3s are common. This blue, marked in blue and purple. 3 times 3, here also 3 times 3, 3 times. But these are not common because you don't have 2 here. So I don't take into consideration. I have 3 here. I don't have any extra 3 here. If any extra 3 would have been here and another 3 would have been here, then I would have taken all the 3 together. So now only I have 2 3s which are common to all. So HCF is 3 into. So by now I'm sure you know what is the difference between HCF and LCM. HCF will always be smaller than these 3 numbers, and LCM will be greater than all these 3 numbers. Okay, that is this, all these numbers should go into this number, and here HCF should go into this and this. So definitely this will be smaller than all these numbers. Okay, just think about it. Go to the previous slides and you will understand. So Euclid's division lemma, this is if A divided by B is equal to C, then A is equal to C into B. And this is how you write it. Suppose A divided by B, that goes, this is a quotient C. So B into C is, you subtract it till you get 0. And if you don't get 0, if you get remainder, say here is A, you divide by B, and this is a quotient, B into Q is equal to Q into B, subtract it and you may get remainder. If you don't get remainder, this R is 0, and if you get remainder, then R has some number. So this is Euclid's division lemma, and here I have said this is divisor, this is a dividend, quotient, and divisor into quotient is this, and if you subtract this dividend minus this, you get remainder. Now a theorem, this is Euclid's division lemma, that given positive integer A and B, there exists unique integer Q and R satisfying A is equal to B into Q plus R, and this R will be smaller than B, and since R is smaller than B, and R can be 0 also. Okay, here we will try to find HCF of these 3 numbers 32, 15 by division method. Suppose you want to do it quickly, and in the question they have not asked you whether to do it by division method or a tabular method. I always like to do using tabular method, but if division method is told, but you have to do this way. So suppose 32 and 56, I take the HCF of these 2 numbers first, and then whatever the HCF I got, then I take the HCF of the result of these 2 HCF with respect to this 46. So here I have doing division. So here 32 goes to 56 one time. So you please go through it. It is very simple. So you get this 32 here. The divisor will become a dividend, and this you divide this one with the remainder. And similarly, so here this is the last divisor. So this is a HCF of these 2 number which we have discussed earlier. Now you have this 8 and then 46, this remaining. So you keep on doing it till you get 0 here. So since last division is 2, we call HCF of 36, 56 and 46 is 2. So use Euclid algorithm to find the HCF of, so that is dividend is nothing but, this is the dividend. Dividend is nothing but divisor into quotient plus the remainder which we will have. So here 56, here I have written, is nothing but 32 into 1. So now this is your 32 was your divisor, you bring it here. So here I have written this thing expressed in this term. Whatever I have got here, I have written here. 24 is 8 into 3 plus 0. And for 46, I again do the same thing. And you keep on doing it till you get 0. So for this, your HCF for 56 and 32 was 8. Then for 46 and 8, you continue. So this is I have written. Actually, this is also called Euclid's algorithm. It's the same thing which I have written it. So HCF of 32, 56, 46 is 2. And here I do using a tabular method, that 32, 56, 2 goes to 32, 56, then it goes to 16, then 2 goes to 8 and 14. So 2, that is 2 into 4. Now there is no common. So I stop here. So HCF is 2, 2, 2, that is 8. So these 3 are common. So 32 is 8 into 4. So this element 32 is nothing but 2, 8 times 4, and 56 56 is nothing but this 8 times 7, whichever. And this 4 and 7, these are the co-prime. That is the number which can be divided by 1 or by itself. There is no common, okay, divisor for this. 2 will not go in 7. 3 also will not go in 7. 4 will go in 4. 7 will go in 7. Or 1 will go in 4. 1. The set of numbers can be co-prime. So they are not, you don't have a common divisor. Now HCF of A comma B is HCF of B comma Y. Means this is called commutative. You will come to know when I say A into B is equal to B into A, that is a commutative property of multiplication. Okay, when I say A plus B is equal to B plus A, that is commutative property of addition. So here this is a commutative property. A comma B is equal to HCF of B comma A. This is common. So it is easy to see that this is, if you take 56, 32, you will say it goes 0 times. So you have 0. So you bring 32 here and you bring this 56 here. So you see again it becomes what? It has flipped. So now I can again do this division method. Okay, 32, 56. If I start with 56, 32, I will get 32, 56 here. That is 56 divided by 32. So 32 divided by 56, I can bring it to this form. And then of course, so if I start with this, I will get the HCF as 8. So HCF of A comma B is equal to HCF of B comma A. Now HCF of A comma B comma C. So this has an associative property. Here I have seen. What do you mean by associative property? That is, suppose A into B into C, this comma you think it as multiplication, is nothing but you multiply first A into B, you get a number here, multiply by C, that this number which you have got is equal to, you multiply this B comma C, this number B into C, multiply it by A, both will be same. So this is associative property. Similarly, this comma can be thought as plus A plus B plus C. So A plus B you evaluate, then add it to C is same as you add first B plus C and add it to A. It will be same. So here also HCF has an associative property. So you find the HCF of this, that is HCF of A comma B, and then you find HCF of A comma B comma C. Here what I have written is equal to HCF of, you first find the HCF of B comma C here, whatever HCF you get, and again find the HCF. So this is an associative property. We will prove this. And similarly, LCM also has an associative property. So there is another interesting property of this LCM, that is product of LCM of these two number and HCF of these two number A and B is nothing but is a product of these two number A times B. So if you have say 32 and 56 A and B, your LCM of 32 and 56 we saw it's 224 and HCF is 8 here. So 224 into 8 is same. You just use calculator and find, and you will find they are both same. So now let us prove this one, that is LCM times HCF of A comma B is A into B. So let HCF of A comma B is C. Okay, of this two number, it says some number C. This is 8 here, and I know that this is the element A. This A is 8 into 4 is 32, and element B is 56. 8 into 7 is 56. This is 2 into 2 into 2, 8 into 7 is 56. So these are the co-prime. So I write A is equal to C times X and B is equal to this C. These are HCF times say some Y, which is 7 here. So B is equal to C into Y, and these two number X and Y are some X and Y which are co-prime by definition of HCF. So when you want to find the HCF, this two number has to be co-prime. Otherwise, if it is not a co-prime, then again you can continue dividing it. So here we show LCM of A comma B. So if I take A and B, and suppose you start that X goes to A C times, but it doesn't go, so I bring this B down, and then I take Y, which may go into B. So Y goes to B say C times. So B is equal to Y into C, and A is equal to X into C, and then you have C and C. C is common, so I multiply by C, I get 1, 1. Just freeze it and go through it, try to understand this. So LCM will be this times this times this. So LCM of A comma B. This I have done many times in the previous slides. So if you have confusion, just freeze it and go back to my previous slide and try to understand this table. So LCM of A comma B is C times X into Y, since X and Y are co-prime, okay, which we have here also X and Y are co. So LCM of A into B into HCF of A comma B. So LCM of A comma B is C into X into Y, and HCF of A comma B is C. So I can write this is C times X, and this Y cross C I can write as CY. So CX into CY, and CX is what? C times X is A, and C times Y is your B. That is A times B. Here also A is C times X, for and your B is also C times Y. Okay. Now we'll discuss theorem that is called fundamental theorem of arithmetic. This is very important theorem that any number, composite number, can be expressed as a product of primes. Okay, so you can break into product of say any number n, you can break it into n equal to p1 times p2 times p3 times p4, and these are all prime numbers. So here it is written that prime factorization, see here I have given how do you do prime factorization of 7744. So you start with 2. So till here 2 will go, that is 2 will go 1 times, 2 times 1. But now 2 will not go here, it become an odd number. So now you got 242, 2 will go in this. So now you have this number 121 which is odd. Now you try next prime number 3, it will not go. 5, it will not go. The next prime number is about 7, that will also not go. So you continue till you come here. After 7 you have 11, and you know 11 will go. So 11 into 11 is 121, then you get 11 and then 11. So now what you have, so 7744 is 2 into 2 into 2, so many 2's, times 2 times 11, 11 into 11. So now if you want to find the square root, it is interesting that square root of this is square root of 2 to the power 6, 1 2 3 4 5 6 times 11 square. So this is any square root means any number, square root means number to the power half. So this will be 6 divided by 2 will be 3, and 2 divided by 2 will be 1. So you have 2 to the power 3 times 11. So these are simple. You should go to my 9th standard, and such things has been addressed extensively. How to reduce this number. So then 2 to the power 3 is 8 into 11, 80. So please go to my class 9 lectures. And this has also been explained more detail in class 9 lecture, rules of exponent. So I will not deal much here. That is when you have a to the power m to the power n, that is m into n, you can write like this. So please go through this and also go through my class 9 lecture. Any number to the power 0 is always 1, and any number to the power negative integer is the reciprocal of this. Okay, minus m, it will go down and it will become plus m. So all these things in detail we have discussed in class 9. So kindly go to class 9 lectures. Now a theorem, let p be a prime number, and if p divides a square, then p divides a, where a is a positive integer. So this can be proved very easily. That is any positive integer a, as I said, from the fundamental theorem of arithmetic, a is p1 times p2 times p. You can always take a product of this prime number. And so a square will be, a is this, so you 2 times you multiply a times a square is a times a. And since p, you have been given that p divides a square, that is this, and since p is a prime number which divides a square, this implies then p is one of this number, because it's a prime number. These are all prime number. So p is one of this prime number. And since a is equal to this product of this prime number, so you can always, hence p divides a. So this prime number which is there, the number is one of them. So this you can cancel it. So hence p divides a also. Just go through it. It is very simple. Just try to understand. Now let us try to understand some more about co-prime. Suppose you have 15. So what is the factor of 15? 1, 3, 5 and 15. And what is the factor of 8? 2 will go in 8, 4 will go in 8. Here 3 will go in 15, 3 5s are 15, 5 3s are 15. Then 15 will go to 15 one time. So HCF of 15 and 8 is 1. So because this is the common, only this is common. And 1 is only common factor of 15 and 18. So 15 and 18 are the co. So if there are some common factor, some other number, if this also would have been 3, then they are not co. Okay, so two numbers having only 1 as a common factor are called co-prime numbers. And to be co-prime numbers, two numbers do not have to be prime number, as we have seen here. And a pair of prime numbers are always co-prime. Okay, if they are prime already, then they are co, because they are only divisible by 1 or by itself. Okay, now let us discuss if n is not a perfect square, then square root of n is irrational. That is, if n is a perfect square, say if it is 25, which is 5 square, so square root of 5 square is 5. So that is not. But some other number, if n is, you cannot write in terms of a square, then it is an irrational number. This square root of 2 is irrational number, 3 is irrational, 4 is not. Okay, square root of 9 is not, but square root of 8 is irrational number, square root of 7 is irrational number. So let us prove this. So let us on the contrary say it is rational. So this we had discussed in class 9 to prove by contradiction. So let on the contrary say it is rational. That is, square root of n is, you can express it as ratio of two integer p by q. That is, p and q are co-prime numbers and q is not equal to 0 and also 1. Any rational numbers, you have to take a ratio of two co-prime numbers. So this condition that q is not not equal to 0 or 1. So now n is equal to, I square it, is equal to p square by q square. I take p square is equal to n times q square. Now since q divides nq square, that is q will divide p square. And from our fundamental theorem of arithmetic, the theorem which is 1.3 in your textbook, here hence q will divide p. But we started with p and q are co-prime integer. But here it is contradiction. Thus p and q are not co-prime. Thus contradiction. Hence square root n is irrational number. So similarly one can show square root 2 is also irrational number. Since n is irrational number, provided it is not a perfect square, then all other numbers are irrational. Okay, now we will discuss terminating and non-terminating rational numbers. Here we will see that this some decimal 0.375 I can write as 375 divided by 1000 because there are 3 zeros. So decimal place here will go 3 times. This is 0.375. So kindly please go through class 9. I'm repeating many times. So all these things are discussed there in much greater extent. So this decimal number I can express here. This 375 by 10 to the power 3 I can write 3 into 5 5 are 25 into 5 is 125 into 3 is 375. You just go through it. I can write this 5 to the power 3. This I can write as 2 into 5 to the power 3 is 2 into the power 3 times 5 to the power 3. This get cancelled. I can write as 3 by 8. So similarly I can write this number, decimal number, as a ratios. Here I've just shown here what 875 is. 875 is 5 into 5 into 5 into 7. That is 5 cube into 7. And 10 to the power 4 is 2 to the power 4 into 5 to the power 4. So this 5 cube will get cancelled with the 5 cube here. So 5 remains. You have here 5 cube, 7 into 5 cube. So I will not, here I have written here prime factor of 875. So just go through this. These are very simple things. So here now we discuss the same thing. This 3 by 8, okay, is nothing but I can multiply 3 times 5 to the power 3, numerator and denominator same number. I get 375, 10 to the power 3. This is 2 into 5 is 10. This 3 is common. So that is 10 to the 2 into 5 is 10 to the power 3. Go back to my class 9 lecture to understand all this kind of stuff. So I have here 0.375. So I can write 3 by 8 like this. Similarly 13 by 5 to the power 3, that is 125 I can write. So just go through it, and here I would like to say that so this example shows us how we can convert a rational number of the form p by q, where q is of the form of 2 to the power m times 5 to the power n. So m, this is a generalized form. M can be equal to n also, to an equivalent rational number of the form a by b, where b is a power of 10. This b is a power of 10. Therefore the decimal expansion of such rational number terminates. So if you can express in terms of 2 to the power n into 5 to the power n, the denominator, then you can say that such a rational numbers are terminating rational numbers. Okay, but if you cannot express in this power, then either it will be repeatable or it may not be repeatable. So we can say a rational number of the form p by q, where q is of the form of 2 to the power n into 5 to the power n, to an equivalent rational number a b, where b is, this denominator is power of 10, then the decimal expansion terminates. So here I say that suppose you have this number p divided by, this is a denominator n and m, this is a generalized way. Then you multiply the numerator and denominator with 2 to the power m into 5 to the power m. Here 2 to the power m is here, this is n here, and 5n is here, m is here. So you multiply numerator and denominator by this, and then you will have here 2 to the power n plus m into 5 to the power n plus m, that is 2 into 5 is 10 to the power n plus m. So I have a terminating decimal expansion. Now theorem, let x be a rational number whose decimal expansion terminates. So this can be expressed in the form of p by q, and this q, since it is terminating, the q can be expressed in terms of 2 to the power n into 5 power m, where these are integer number. So or vice versa is also true. If q can be expressed in this way, then the decimal expansion terminates. So this is the next theorem. So it says let x be p by q, be a rational number such that prime factorization of q is of the form of this. The q is of this form, where n and m are non-negative, then x has a decimal expansion which terminates. So whether if decimal expansion terminates, then you have the denominator in this way. If you have denominator which terminates this way, then the expansion, decimal expansion terminates. So vice versa, both are same. Now another theorem, if x is p by q, and if q you cannot express in the form of 2 to the power n times 5 to the power m, then then this decimal expansion is a non-terminating repeating. So it will not terminate, is a non-terminating one. So here now again I give a tree diagram. This real number is rational number or irrational number. So here rational means you can express it as ratio of two co-prime number, and this is an irrational number where you cannot express as a ratio of two integer or two co-prime number. So in rational number, if you divide the number, the dividend by a divisor, and if you get remainder 0, then it is terminating and non-repeating. But if the remainder is not equal to 0 and the remainder comes back to the dividend like we have seen, so it will make a cycle. So you start with the dividend with the divisor, and once you go again you repeat, so you will have non-terminating and repeating recurring. And if remainder is not 0 and remainder is not equal to any dividend, so this will be non-terminating, non-repeating. Okay, this is an irrational number. So these are the example. Example is 18 by 5, 3.6, 1 by 3, and here it is non-repeating. It can go on forever. So here I have written this dividend divided by divisor, divisor into quotient, you will get some number, divisor into quotient here, and remainder. So based on this, you just freeze it and see. So now let us see how to find the square root of a number n. That is, what is the value of square root of n? Say it is x. So I can square both the sides. Square root of n square is n, and that is x square. So this n I bring it this side. So I have x square minus n equal to 0. That is, this is a function of x. That is f of x is equal to. So if I can find the root of this function, that is at what value of x is equal to this function is 0, then I know what is square root n. So how do I find this? I write, this is your y-axis, this is your x-axis. Y is the function of x. So here at point x0 it is f of x0, and at x1 it is function of x1, f of x1, so and so on. So at x0, what is the slope? Slope is rate of change of y by rate of change of x. So if I draw a perpendicular line here, and from here one perpendicular line here, so this distance by this distance, or in other words, since this line has a constant slope, is linear line, slope here and slope here everywhere is same, so I, for my convenience, I write the slope of this line as dy is f of x0 minus 0 divided by, this is, it intercept here x0 minus x1. That is, here I have written here the slope at x0 dy by dx is x at x equal to x0 is, this is the notation. I write the dy by dx as f prime. The derivative of f of x with respect to x I can write as f prime x0, and as I said earlier, it is nothing but f of x0 minus 0. The y value here is 0. Here it is f of x0, so y2 minus y1 by x2 minus x1. So x2 is here, is your x0 here. Okay, there's a slope which we have studied in class 9. Slope of any line is given by, suppose you have 2 point x1 comma y1 and x2 comma y2. It is the change in distance y2 minus y1 in the y-axis divided by x2 minus x1 in the x-axis. So this is what I have written here. So go through my class 9 lecture, you will understand this definition. So now I can rearrange this term. I take this denominator to the other side, it becomes numerator. As you know, in class 9 we have discussed this, that when you take from left hand side to right hand side, numerator goes to denominator and denominator goes to numerator. That we have studied. Please go through my class 9 lectures. So now once I rearrange this x0 minus x1, I take it here, that is f of x0 by f prime x0. So then I can again rearrange this. I take this x1 this side and bring this, so I get x1 is equal to x0. So for this blue triangle here, this is x1 equal to x0 minus f of x0 by f prime. Similarly, for this red triangle, I can write x2 is equal to x1 times f of x1 divided by f prime x1. You can find this along this line, and similarly, if you continue, you will get x of n plus 1 is equal to x of n minus. So this is 1, 2, this is 0, 1. So this is n plus 1. One number more than this is n, so this will be n plus 1. If it is 0, this is 1. If it is 1, it is 2. If it is 2, this will be 3. So if you continue, you will have x of n plus 1 equal to x of n. Okay, function of x of n divided by derivative of this function. So as n becomes larger, this x0 will move towards xn, that is x1, x2, and it will go to this point, and that is the solution. That is, at this value of x, f of x is 0. Okay, so this thing will go to 0. So this is reducing and slowly will go to 0 as this x0 approaches to xn. Now f of xn you can write like this. Here this is a f of xn is xn square minus n, and so f prime x This is the thing which I'm introducing for the first time, but maybe we have discussed this in class 9. So here f prime indicates derivative of the function f of x. So this is here at x equal to xn. So I can write this as f of x plus delta x minus f of x by delta x, and here limit of dx tends to 0. This is the definition of a derivative. So how do you understand this? This is your y of this is this y. So suppose this is the point x. So instead of x naught I call it x. So x plus delta x, okay, and f of x plus delta x will be somewhere say here, minus of f of x will be somewhere here, okay, this y-axis. So this is your dy, and then delta x, that is this distance, say x plus delta x, this is your delta x. So this is the derivative, and this is, you make it smaller and smaller and let dx tends to 0. So you write at limit of dx. So you will study more on your higher classes, and this I might have discussed this in class 9. Just go through it. So now take it as a definition. You have understood why this definition, we write it like this. So f of x plus delta x minus f of x. So function is f of x is your x square, no? So x plus delta x will be x then plus delta x the whole square, and this is xn. So we are doing at position at x of sub n. So now you expand this is xn square plus 2xn delta x plus delta x square minus xn. This xn and xn square will get cancelled, and you will remain with 2xn delta x, and this delta x and delta x will cancel, and then you will have delta x square. So you are taking limit of delta x tend to 0. So only 2xn delta x remain, delta x and delta x cancel, so you have 2xn. Just solve it. This is very trivial. So now I use this formula, xn plus 1 is equal to xn. This is xn, and derivative of this is your f of xn is nothing but this is your f of xn, okay, x square n minus n. Actually derivative of this number will be 0 because this is not a function of x. So you should only consider this. So anyway, more detail you will see in higher classes. So now I simplify this. This is xn square, this xn and xn cancel, xn by 2 is minus, and then plus, this minus into minus plus. So this is equal to now xn minus half, means 1 minus half is half of xn, and this. So I take a half common and I can write. So calculating the square root of a number using Newton-Raphson method. So this is the Newton-Raphson method which I have described, and the formula is xn plus 1 is equal to half of x of n plus n by x of 7. This is the formula. So let us see how to calculate for one particular example. Now let us apply Newton-Raphson method to approximate square root 3. So now we need to solve equation f of x is equal to x square minus n. N in this case is 3. What we did last time, equal to 0. And f prime x is just 2x, okay, it is 2x. This we have shown earlier how to get it. Derivative of x square is 2x, which we did in our previous slide, and we use now this formula. And once we use this, say x naught, since I start with n equal to 0, then I will get 0 plus 1, so x of 1, so f of x naught, and this is f prime of x. So I use this formula, x1 is x0. So f of x naught, I know this x naught I am taking, assuming as 2, because square root of 3 is somewhere between 1 and 2. I know because 2 square is 4, so somewhere less than 2 it will be. So I start with 2, and f of x naught is, x naught we have taken as 2, so 2 square minus 3, and f prime is 2 into x naught. So 2 into 2, this x naught is 2. So I get 1.7. So I continue x2. I take this x1 1.175 here, and then I substitute f of x1. Okay, x1 is 1.175. So I do similarly, and this twice into x1 from the formula, and I continue to x3 also similarly. I get it is approaching to some constant value, and similarly if I use this formula, that is that Newton-Raphson method, I also get very similar thing. Again I take x naught. So both are very similar, and here x1 is equal to this half, x naught is 2, n is 3 by 2, 1.75, x2 is, again I take x1 here, substitute here, I get this, and x3 is equal to, I substitute this is your x2, no, x3 is equal to this is 1/2 of x2 I got here, then 3 by x2. So see, in 3 terms I get same answer. So this is how you can find the square root of a number using Newton-Raphson method. So we will learn in higher class much other quicker method to do so, but it requires some complicated maths. So kindly go through this summary. I'm not going to read it. Either pause it or go and see in your textbook and see whether we have covered all this. And I think mostly we have covered. And this you just pause and go through it. And thank you and see you in next lecture.